Hey everybody, thank you for joining our podcast today. I'm here with Gary Hill, our industry advisor. I appreciate Gary being here today. How you doing, Gary?
Hey, Pete, doing well. Thanks for the invite today. Look forward to the session.
Yeah, no, I think it'll be good. We had our prior discussion around the connected factory in general, and I think today we wanted to kind of focus more on the use case side of things and just provide some information out there. But before we get into the presentation, maybe if you could do an introduction of yourself, that'd be great.
Yeah, thanks, Pete. Yeah, so Gary Hill, industry advisor for Future Technologies. I spent over 30 years in a large manufacturing company, Georgia Pacific, consumer goods manufacturer. Last 10 years as chief technology officer, focused on enterprise architecture, factory of the future, and emerging technologies. So yeah, I have quite a bit of experience kind of in manufacturing and how to apply technology to drive business value.
Great. I think for today that's it's going to be a focus area for us. So I think it'll be good. I'm Pete Cappiello, CEO of Future Tech. Been with the firm for about 13 years now. But for today, I'm just going to play moderator and make sure that the slides roll well for Gary. So that said, let's get into the presentation. So our goal today is to talk about use case benefits. We're going to do a deep dive into use cases in general. You can see on the right-hand side some example use cases visualized there, but we're going to get into those more specifically. And at the end, we put a couple matrix together to talk about how connectivity helps enable these use cases. So we have a technical matrix, and then another matrix that talks specifically around what connectivity supports what use cases, and just providing a little bit of a table of data. But to start things off, I'll defer to Gary to talk about why we're talking about use cases in general. What's the business benefits of those?
Yeah, thanks, Pete. So, Industry 4.0 is a big topic today for all manufacturers. And, really that is, really the journey from, kind of automated production today with PLCs and some level of automation to a future really of more autonomous production, right? Internet of Things, pervasive connectivity, smart factories. So that's kind of the context of the discussion. Obviously, that's a journey for every company's at a different point, and maybe we make it to autonomous production someday, but that's probably probably a decade or so journey to get to that for most companies. However, I think as people are going through their journey and making improvements in their automation, improving their manufacturing process, there are some common themes, and really it's around the business benefits. So regardless of where you're at in your journey, I think these four benefit areas are something that most companies should be focused on, because certainly these are the things you're going to measure. These are the reasons we're doing quote connected factory industry 4.0, and obviously productivity is a big one, using technology to keep increasing that productivity, right? And we've seen that for decades in manufacturing, of new technology keeps increasing that productivity. So it's really, this is how do you take that to the next level to get better asset utilization, better inventory management. And we're all being challenged to be more productive in our operations. I think the other thing too we're seeing as a benefit around Industry 4.0 and some of the new technologies is bringing more flexibility to your manufacturing operation. So robots, new machines that can execute your production steps, maybe more flexible. You can change your production faster. You can retool your operations in a much more flexible way versus, 15, 20 years ago, you built a production line, that thing's going to stay in place probably, until those assets are written off the books. Another area too that everybody's still after is quality. How do you increase your product quality? I think the current technologies really has an opportunity with sensors and actuators to make quality more of a real-time type opportunity. So you can quickly intervene with errors in manufacturing, with today, maybe you make 1,000 units, you realize you have a quality issue after the fact. I think now you can start doing that more real time. And obviously speed, we're all after doing things faster, more flexibility. We mentioned earlier, but the speed is how do you go from your, first factory idea or a new product, and then replicate that. So, using simulation capabilities and making it more a data-driven type manufacturing process. So again, I always keep these benefits in mind as I'm talking about either the technology or the use cases, and how do those use cases or the technology drive back to these benefit areas. So Pete, you want to move on to maybe start on the use case slide area. Yeah, so whenever we talk about quite often, this is, some people call it AGV, LGV, but it's really around using robotics to move raw materials, finished goods, warehouse management. Huge opportunity for productivity. There's also opportunity to increase your safety here. But again, seeing a lot of companies shifting to more of this in their manufacturing operations. A pretty big capital investment to go this route, but I think the long-term benefits are pretty extensive. And again, you look at some of the cases on the right-hand side, big paper rolls being moved around autonomously within a manufacturing operation. The bottom one, I think that's an Amazon warehouse, basically moving pick bins around to be more efficient in their warehouse management picking operations. So many sub-use cases, but AGVs are really starting to really bring that autonomous operations to many manufacturers and logistics places. Connectivity wise, again, an opportunity. You have to have really, I think, great connectivity as these robots are moving around your facility. You have drops in connectivity. You can really sub-optimize the benefits that you were trying to create by putting this technology in to begin with.
Yeah, from a compute perspective, I mean, these are probably low latency type applications. So, in scenarios like this, beyond the connectivity, maybe moving some of the compute to the edge, provides some additional benefit as well. That's something that also needs to be considered, right?
Yeah, that's a great point. And a lot of these use cases we'll talk through today is, where your compute is located is pretty important because most manufacturers are keeping a significant amount of their compute at the edge. We are moving things to the cloud for analytics, for things, but for autonomous operations, things that have real-time implications in manufacturing or logistics. Yeah, Pete, that's a great point. A lot of that compute, those applications are going to run locally and then talk to the cloud to augment their capabilities.
Yeah. Oh, great.
Go to the next item. So this is one I really like too, again, around a more generic robotic and drone use cases. But, we see this in our personal life of, the drone you get your kid for Christmas, or you get it for yourself, perhaps. Pete probably has one of those. But really, the application of these in operations and manufacturing is actually something we're seeing a lot of uptake in. Now that the FAA has, clarified some of the rules of how you use some of these in commercial setting, we're seeing some huge value cases. So just to cut some examples here of the flying, the drone is, using that to do inspection of hard to reach assets. So many manufacturers have things they have to inspect. So they have to build possibly scaffolding, send people up these huge scaffolding things to go look at a building or a piping. So again, using this to basically go do that in a safe way, high resolution video. Actually, you have a recording of the video. So again, you're saving money because it can be done more quickly, and you're improving your safety. Another pretty cool example of some industries, have raw material stockpiles. So maybe a forestry operation, mining, have big stockpiles. And today, they have to estimate their inventory through either drive-by, flying an airplane over. Many use cases, hey, I can go fly a UAV over that stockpile, have an algorithm that within minutes kind of gives me a real-time inventory update. So, hey, the robot too on the bottom picture there, seeing more use cases there in manufacturing. Obviously in manufacturing, there's still a lot of hazardous areas, high heat, gas, just unsafe places, you really don't want to send people into. So be able to use these little inspection robots as a way to do that is seeing a lot of, I think, uptake in the industry. And even some creative ways of using robots for inventory counting. I know you've probably seen the example of Walmart using a robot to count inventory in the stores. Well, same thing can apply in a warehouse, raw materials of using that technology there. Again, connectivity is pretty important here, indoors and outdoor type coverage. So combination of Wi-Fi and maybe some LTE coverages, what you're going to be looking for.
Yeah, on the robotic side, one other thing that we've seen is perimeter security robots. Sharp, for example, came out with a robot for perimeter security, especially in some of these locations where, to your point, there's safety concerns. But we've seen that industry also starting to pick up, and maybe as it matures and becomes more affordable, we'll see that more deployed regularly.
Yeah, we'll continue to see this area grow here too. The price point on all this technology also continues to fall, so as it becomes more affordable, more robust, obviously more use cases will be tried by manufacturers. So let's go to the next use case area. Yeah, this one we're calling kind of a broadly connected worker platform. So again, think of this as you've got people today on your shop floor in your manufacturing operations, still with a lot of manual work. If you go look at your work processes, many today are still paper-based forms, people filling out forms. Hey, people going to fix a piece of equipment, they have to go get the physical manual out of the library. So think of this as really how can you take some pretty, I'd say, mature technology, tablet computing, and really start automating and digitizing your manufacturing workflow. So from manual work task, paper-based to digital forms. There's a great example there, just on the top of, kind of digital versus paper form. Also, standard operating procedures. So that I like the example there of, hey, so if having paper-based instructions, you can have digitized, which maybe provides a video, a short how-to. Think of, you using YouTube personally to how do you fix an item. So it's really digitizing that whole connected worker environment. And also a chance to, I think, automate manual workflows, alerts, approval processes. So I think this is a pretty much low-hanging fruit, I think, for many operations. This is fairly straightforward to do. Again, the technology is relatively mature, and again, it's a way to start digitizing kind of your operations and your processes. So again, some benefits are better productivity, efficiency, hey, reducing errors of writing things and reading things off of a piece of paper. Hey, improving your safety and adherence to standard operating procedures. That's a pretty big driver for most manufacturers. And then also getting more real-time visibility to what's going on. Think of today in your manual paper-based processes, an operator may record something. It may sit in a stack of paper, get rekeyed in a day later. For if you're doing this more real-time digital, you're getting that real-time visibility as soon as that information is entered. I think this also has an upside of faster, better training of new workers and operators. So more of your digital natives coming into the manufacturing space, people are more comfortable with digital. I think this can help get a new operator, a new worker, much more streamlined to your processes faster than the old paper-based process. Again, connectivity-wise, you're going to need some level of Wi-Fi or cellular. Many of these solutions are designed to work offline, so when connectivity is lost, you can still fill the form out. So again, I think this is an area I would say is still pretty low-hanging fruit for many operations. You go look at your processes. How many things are you still doing manually on paper? And again, many platforms in the market that can start digitizing. So I think a good opportunity for manufacturers to revisit this opportunity. What are you seeing, Pete, in some of the clients we have today?
Yeah, no, I mean, we see across the board that digital workflow management is becoming more and more relevant. And it's connectivity agnostic. As long as there's connectivity, because it's not a big data hog, it doesn't require low latency. So it's more just a matter of adoption. But we see it as a nice use case, whether it's riding on the existing Wi-Fi, either or on the public network, and then with the advent of private LTE, I mean, any of those connectivity solutions work for it. But it definitely adds a lot of value. Like we have a mine customer that person would have to drive. It's controlled setting, 25 miles an hour. They would drive out a few miles to do a work order, and then have to because of the lack of connectivity at that mine site, actually return all the way back to their check-in point to get their next work order. It was very, restrictive in that regard. As they moved to digital workflow and built the connectivity, they were able to be much more efficient with their same resources. So we've seen a very simple thing like this go digital and have the right connectivity, and it makes a big difference from a business perspective, and also driving operations to be more efficient.
Yeah, absolutely. Let's go to the next use case item. Yeah, remote expert solutions. So some people maybe classify this in the AR, VR, augmented reality, virtual reality kind of category. To me, it's more of the augmented reality. And really, the reason we call this remote expert is usually really using AR technology to let a remote expert, someone in a distant location, help an on-site resource. And this has been very impactful during COVID. Many manufacturers have not been able to fly their experts, maybe their vendors, into a manufacturing facility to repair a piece of equipment. So they've been able to use this technology to have the local person, maybe wear a headset like there on the top picture on the right-hand side, or use a tablet or a smartphone to really walk around in the facility, use the camera technology to let the remote experts see what they're seeing, talk to the individual, annotate on the screen. Again, COVID has driven these solutions in the market to, I would say, almost a necessity today. So again, a lot of these, leverage a headset, a tablet, a smartphone, and again, certainly connectivity is required. Remote expert is typically going to be in a different city, different state. I've worked my prior company where we had vendors in different parts of the world coming in and supporting us. So, good connectivity, Wi-Fi, you're backed out to your internet is pretty important for this. And, there are even use cases for outdoor type use cases as well in an operation. So again, COVID has driven a lot of uptake of this in the market. And again, I think what I'm predicting is many companies will kind of, even after COVID moves away and the travel restrictions lighten, this may just be a better way of doing business. I can get the same positive support from an expert, less cost, less downtime with an individual traveling. That now expert can be applied to many more locations. So I think this may be a new way of doing business, post-COVID. And the technology, again, is pretty robust, pretty mature in this space.
Yeah, no, I mean, we've definitely seen that. We actually deployed a private cellular network for a mine up in Canada without going to the site this year. So they had a business requirement to do private LTE. We couldn't get access to the site, so we did a remote site survey using local hands and feet to provide us access, designed the network, integrated the network in our controlled setting in Atlanta, and then shipped it to the customer site. And we supported a full private LTE network being deployed without actually stepping on site. Not only did it work, it actually outperformed what we had designed. And, we had to do that because of travel restrictions, but it's kind of an aha moment of, if we're spending less time traveling and more time doing, it's more efficient for everybody. We can drive, cost efficiencies to our client and enable things that, maybe before we'd have constraints with schedules and whatnot. So I definitely agree that, we're forced to innovate because of this environmental condition, but I think, there's definitely going to be learnings from that are going to apply going forward.
Yeah, and maybe kind of how this ties back into the connected worker, most of these solutions too can record the sessions that are occurring. So you can also use this as training. So, hey, once an expert has now walked you through fixing an issue, that video can be cataloged, put into the training material, to your operations maintenance material. So there's also added benefits beyond just the connectivity. Is now I have a digital representation of that session that can be leveraged the next time that issue comes up. Let's go to the next use case. Yeah, so asset health is a broad area for manufacturers, and I would say as companies go to kind of to achieve operational excellence, this area is probably has one of the biggest financial upsides for most operations, most manufacturers. Really the largest bottom line benefits. So again, pretty broad category, but things like unplanned downtime for manufacturing assets is a major financial impact for most companies. Hey, kind of helping you shift from reactive maintenance to proactive. No one wants a major piece of equipment going down unplanned. It disrupts the supply chain. Oftentimes the an asset, is more when you're having to do it reactively. Think of changing your oil, right? You want to change your oil before your engine blows up or seizes up. So, again, doing that sooner, proactively and predictively with technology is a big case there. So, one example I just want to highlight here is wireless vibration monitoring, how that's being used for asset health. Again, a lot of existing assets in manufacturing don't have vibration sensing built in, so you have to send your vibration techs out to manually test equipment throughout the week, throughout the month. You typically can't go test all of your equipment all the time. So some new solutions in the market let you put a wireless vibration sensor. It's typically magnetic, can stick it on a motor, anything where vibration could be an issue. And basically it's monitoring in real time, collecting that data, typically sending it to a gateway there on site, and then store and forward that up to the cloud. And then basically they're looking back to the chart on the right-hand side of really any anomalies. You can see, hey, here's what a vibration pattern looks like for this asset. And when you start seeing deviations of vibration going up, typically a really good indicator of some problem with that asset. So I've seen companies experience typically each time they proactively find vibration going up and doing proactive maintenance, they're typically saving, anywhere from $100,000 to $500,000 relative to that asset going down reactively. So pretty big value for manufacturers. I think the other thing too we talked about, Pete, too, is here where you get more and more sensors in manufacturing. This is just one example. Everyone is sensoring up every manufacturing asset, right? Temperature, vibration. We're putting cameras into manufacturing as another sensor, really around asset health. So you get this in-device density where you may have thousands of devices in your environment, sensors collecting data. So really, you have to be thoughtful about your network, the connectivity, how many devices. So you could have thousands of sensors in the future wirelessly communicating. So pretty exciting area for manufacturing. Again, huge upside, huge benefits here. But a lot to think about when you're planning your network and how you're going to even go pilot this technology, right?
Yeah, no, 100%. I mean, and there's great options for connectivity, whether it's migrating to Wi-Fi 6, looking at private LTE, or ultimately looking at 5G. The density is something that you have to consider, but lots of good connectivity options there. But it's a game changer, because if you could proactively through different applications look at preventative maintenance, it just keeps your uptime so much more in line with the business objectives.
Yeah, again, back to those business benefits. So productivity and uptime are pretty big. Let's go to the next one. So environmental health and safety. So again, another great example of all manufacturers are challenged with EH&S, operating safely, operating in environmentally okay ways. So a lot of companies are trying to use this technology, sensors and cameras, and help them monitor that environmental and safety issues in kind of that near real time mode, enabling a rapid response to those conditions. So again, it could be sensors, it could be leak detection, could be water level, could be pH, could be cameras are also becoming pretty big with computer vision, using cameras. So think about EH&S. Typically, these are done by people in the manual way of walking around, looking at conditions, measuring conditions, driving across the facility, taking measurements. So think about, hey, just putting sensors in those places and real time monitoring that data. So this is having a pretty big uptake in manufacturing. Just a couple examples here. One is around leak detection. So this is a computer vision application. Have cameras positioned around the facility. and able to see, if something starts leaking out of a valve or a pipe in this operation. So again, typically that's somewhere where an individual, a person would catch that on a manual round, hopefully. But now with this technology, you could be caught near real time. You can respond more quickly. The example at the bottom too is an operation using water level monitoring and pH monitoring. So they need some power here. This is a remote part of the operation. It's outdoors, so some sensors to monitor real time. So again, another great case for Pete for the computer vision we didn't highlight here, but is safety zone monitoring. So safety continues to be a big challenge for manufacturers trying to increase their safety. And using computer vision cameras, algorithms to detect and see where people are moving into maybe unsafe areas in an operation where they're not supposed to be, and be able to do real-time alerting, either through a siren going off or flashing lights. So again, just tons of use cases with the whole EH&S area for computer vision and IoT sensors. Again, needs some level of connectivity. Sometimes Wi-Fi is sufficient. It just depends on your use case. But again, I think first you start with the use case and then look at, hey, what connectivity do you need to enable those?
Yeah, especially, leverage everything that you currently have and then add where you need to. I mean,
Absolutely.
a big focus for us is like, there's already been investments made. Let's use those existing assets and then supplement, because there's a business justification. Maybe there's a range, from a distance perspective that we have to look at, or, higher quality of service. Those are the things that kind of drive that.
Yeah. So another trend we're seeing in Industry 4.0 with technology, you just can't, you need to talk about, is really industrial 3D printing. Again, this trend has been there for a number. There was quite a bit of hype, let's say 10 years ago, that 3D printing would replace traditional manufacturing. And we really haven't seen that like many people predicted. However, many manufacturers are using 3D printing to drive value, different use cases. So maybe product prototyping, so instead of mass production, they're using 3D printing to do prototyping, so they can turn around a product prototype much more quickly, do that in-house. And there's some use cases of maybe some replacement parts that are difficult to get in the market, or an older piece of equipment. I can't buy the replacement parts, so using 3D printing for that. We're seeing some low volume manufacturing use cases. So for custom manufacturing of custom type things, obviously those are still good value use cases. And also seeing a lot of it in the medical field, medical use cases of surgical implants, replacement limbs, dental pieces. So again, I think you're going to continue to see additive manufacturing, 3D printing continue to grow. Again, it's a lot of it has been about the cost. So we are seeing innovation drive down the cost of 3D printing, but an industrial grade printer still can be relatively expensive here. But we'll continue to see this grow. In fact, Pete, I saw a deal where someone has printed a house. So thinking about not just this technology for smaller items, but for additive manufacturing for bigger use cases. So you may want to consider that for your next home that you build.
Yeah. Yeah. I mean, we're even doing it in-house where, sometimes we have to create a custom casing or something where we're doing a 3D modeling and some printing for prototypes. But no, it's definitely something that we're seeing, and it's more approachable than it used to be.
Absolutely. It's good. Excellent. Digital twin. So yeah, a lot of hype in this one too in the market. And really, I think of a digital twin as just a digital representation of a physical asset. So it's that picture there at the top, you can see the engine. And I think GE and some others have kind of made great progress here, really having a digital equivalent of that engine. And then there's data feeds coming off of that physical asset, feeding the digital model. So you can get real-time monitoring of that asset. You can also do what-if scenarios with, if I have the digital representation of that asset, I can make a change to that asset digitally. Go do some, scenarios, some simulations to see, hey, how would that asset really change or react if I made this change in the physical role? So again, this is becoming more real. I think another use case we've seen too is using this for virtual commissioning. Back to some of that remote expert is, hey, auto manufacturer basically had a digital twin of their operations line, and was able to basically have a remote team configure, set up that line, and commission that line remotely, and not having to be physically on site. So again, a lot of possibilities here. Again, this is typically for more advanced type of manufacturers, but I think you'll see the technology, the prices go down on this, and also become more viable for really all manufacturers over time.
Nice, nice. I appreciate that, Gary. I think those are great use cases that we can think about, and maybe some of our clients are already there, some of them are looking at them, but connectivity is important. So again, we're not going to go through these slides, but we wanted to kind of map. These are some of the technical components that you should be looking at: public LTE, private LTE, Wi-Fi. Bottom, we provided some evaluation of total cost of ownership. We're going to have follow-on sessions to talk about the connectivity, so feel free to use this slide as a starting point. And this slide here is a use case matrix that kind of evaluates the different use cases against the connectivity types. It's not a one-size-fits-all. I think it's very customer dependent on what they're really trying to do, but we wanted again to provide this artifact, and we're going to have a follow-on session to drive into this a little bit more. But I think for today's purposes, I think we basically accomplished our objectives of driving into the use cases and a little bit more specificity. We'd be happy to set up some follow-up discussions. If you're interested, reach out to Chris York, our VP of Sales, and he could coordinate time with Gary and our team. But I definitely appreciate your time today, Gary, and look forward to our next session.
Yeah, Pete, enjoyed it. Have a great rest of the day.
All right, thank you. You too.
Take care.